Okay, we will come back. Actually, this is your figure 13. I have showed you. This is figure 13. Now, next is that figure 14. Right. This is figure 14. So, before telling anything, so just we will look at the figure. This is actually cloud. So, upper portion is the positive charge concentration and lower is the negative charge. So, on the ground there will be a positive charge. Right. So, this is actually figure A. Right. So, what happened? Actually, this lightning stroke, whatever you see, it does not happen instantaneously, it jumps actually. So, what happens that your as a negative charge builds up in the cloud base, a corresponding positive charge is induced on the earth as shown in figure 14a. So, the actually on the cloud base it is negative charge. So, a positive charge will be build up on the earth surface. This is earth surface or ground, right. So, the voltage gradient in the air between charge centers in cloud or between cloud and earth is not uniform. That means, that voltage gradient, right, either suppose either two clouds, either between the clouds, right, or between the cloud and earth, right, that voltage gradient is not uniform, it is not at all uniform, right, but it is maximum, right, where the charge concentration is greatest. So, in that case that means here it is in the diagram it is showing only one cloud there, but wherever charge concentration is high, the voltage gradient there it will be very high, right. Now, what happen actually when the voltage gradient becomes 5 to 10 kilovolt per centimeter, right, either between the clouds or between the cloud and the earth, right. So, voltage gradient within the cloud build up at the order of 5 to 10 kilovolt per centimeter, the air in the region breaks down, right, an ionized path called leader or leader stroke starts to form, moving from the cloud up to the earth as shown in figure 14b. I mean, what happened that if the voltage gradient it becomes at 5 to 10 kilowatt per centimeter, right, what will happen surrounding airs you will be ionized, and at that time what will happen that your that air will be ionized and break down. So, what will happen, a leader or leader stroke start to form. You can see that when lightning is happening, such kind of several lightning your leader you have seen like a root, right. So, here also this kind of your leader, this is called leader, this kind of thing will happen, right. So, what happen that and what will happen that it will try to move from the cloud to the earth, ultimately it will come to the earth, right, and that is actually moving from the cloud up to the earth as shown in figure 14b, this one it is moving up to the earth. So, once happen that tip, the speed of this lightning, it is not the speed of the light, but its speed will be 1 into 10 to the power 5 meter per second to 2 into 10 to the power 5 meter per second general, right. So, that is why its speed will be 10 to the 1 into 10 to the power 5 to 2 into 10 to the power 5 meter per second and moves in jumps. It is not a continuous, because it moves in jumps. So, that means because that your air breakdown, that is your gradient, it is not uniform, it moves in a jump, right. So, if you take if you photograph by camera, if you try to take the lens of which is moving, I will show you from left to right, the leader stroke would appear as shown in figure 15. I mean, if you take the photograph like that from left to right by camera, this leader stroke it is moving like this and finally it is coming to this one ground. So, basically it moves in a jump, it is not a continuous, directly it is not coming from the cloud to the earth, right, it is not reaching near the earth, it moves in a jump because of that ununiform distribution of the voltage gradient, right. So, that is figure 15. Next is, so actually that means what happened, it is a progressive breakdown of the arc path, right. So, that means the formation of the of a lightning stroke is basically a progressive breakdown of the arc path instead of the complete and instantaneous breakdown of the air path from the cloud to the earth. So, it does not come instantaneously, but it is your what you call, it is a progressive breakdown, right, of the arc path. So, that is why that your what you call leader stroke moves. So, as the leader strikes the earth, right, an extremely bright return streamer called return stroke propagates upward from the earth to the cloud following the same path as shown in figure C. As soon as these leader strokes come to the earth, immediately from the earth actually what will happen, that a return stroke will be going from this your earth to the your what you call to that cloud. So, that is why as the leader strikes the earth, an extremely bright return streamer, we call streamer, called return stroke, propagates upward from the earth to the cloud following the same path as shown in figure C. It will follow the same path, right. And figure 15 also, this is your figure 15, that return stroke. You look at it here also, you look return stroke, return stroke, return stroke. It follows the dot leader will come later, right. So, return stroke. So, in that case, in a sense, the return stroke establishes an electric short circuit between the negative charge disposited along the leader and your electrostatically induced positive charge in the ground, right. So, return stroke actually whenever it connects, it makes an electric short circuit, right. So, when lightning happen, you have seen on a suppose on a tree, right. So, what happen that there will be heavy accumulation of the positive charge on the trees, right. And then when there is a return stroke, when it moves following the same path of the leader stroke, it that means from the top of the tree is moved to the cloud and it makes an electrical short circuit. That is why you see the tree is completely burned actually, right. So, sometimes it may happen that suppose you are walking you are on a street, plain street, maybe lightning strokes happen on the plain road also, and you can find that your as if it has happened in front of you, but it is not, right. Then a person will never survive, right. One day one of my students told me, sir, I have survived today because of lightning stroke. What happened? Sir, in front of me that there was a heavy flash on the road and light flash, and there was a lightning stroke on the road. I said it never happened in front of you, at least 500 to 1 kilometer away. So, that is why that light is so bright actually that it will happen as if in front of it is happening in front of you. I also experienced once or twice on the in this thing that on the video recording. I do not like to tell that, and only what incident is very funny, that I was coming by car. So, my driver was driving, all of a sudden on the long road, all of a sudden there was a lightning stroke on the right side of the road. My driver actually brake the car. So, car stops. I said we both are alive, that means it has happened at least 1 kilometer away from us. So, seeing that, he actually braked the car, right. But after moving at 600 to 700 meter, we found the right side of the road there is a big hole and there was a lightning stroke on the road itself. So, it is not like that it will be on the top of the tower or building or this thing. Lightning can happen, lightning stroke can happen even in the plain place also, right. So, this I have observed this one. Another one from railway station somewhere I saw there was a lightning stroke, I think on the coconut trees, and the tree totally burnt actually from distance, right. So, anyway, so that means then this happens because of your return stroke also, because it makes the electrically or what you call electrical short circuit, right. So, this is actually your what you call induced positive, this I have told you. Therefore, the charge energy from cloud is released, right. It is a heavy energy, right. Its lighting current is very high actually, right. So, the charge energy from the cloud is released into the ground. So, neutralizing the charge center, right. So, that means that because all the your what you call all the energy will be released from the cloud. So, the initial speed of the return stroke is 10 to the power 8 meter per second approximately, that not your equal to the speed of the light. Light is 3 into 10 to the power 8 meter per second, approximately 10 to the power 8 meter per second, that the initial speed of the return stroke, that means this one, right. This one occasionally you can observe also it is moving from the as if from the ground or from the trees to the this one, right. So, and its value, the value of this current is 1 to 200 kilo ampere, right. That means 100 kilo ampere which is 1000 ampere to your what you call 2 lakhs ampere. So, imagine its strength or intensity, right, and it lasts about hardly 100 microsecond, right. It is very fast phenomena, but about 40 microsecond later a second leader called dot leader may stroke, usually following the same path taken by the first leader. I mean, once this happen, there is a possibility that there will be repeated your what you call your return stroke you follow the same path. For example, there is one diagram here, this 15, this is the dart leader, this I mean main stroke already, main lighting stroke already has happened, and after that there may be many with a smaller strength, of course dart leader also you can see it, right, as many as maximum as many as 40 you can see, but if you see carefully you will see at least after the main your thing there may be few your return stroke also, they are called dart leader, but intensity will be less than the main one, right. So, and gap between the main and dart will be about 40 microsecond, very small time. A second leader called dart leader may also stroke usually following the same path taken by the first leader, almost the same path, but here in the diagram we cannot show the same path, then you cannot see anything, that is why little bit this thing, but pattern if you see that both are following the same path. So, that is your what you call the same way it will move, little bit zigzag way, right. So, the dart leader is much faster, has no branches and may be produced by discharge between two charge centers in the cloud, right. So, as shown in figure 14e. So, this is your figure 14e, right. So, it may be this may happen, right. One, this is this one, then your 14d also, that your what you call that dart leader, and here also dart leader, and this one also, right. So, note the distribution of the negative charge along the stroke path. If you see the distribution, here it is positive, negative, here it is negative charge. Now, here it is dart leader, look positive, positive, it is negative here, that means here it is positive, here it is negative. So, this path will follow, this will be follow. So, this look, this is ground negative, sorry positive, this is negative, here also it is negative, right. So, this is this similar phenomena, here it is positive, here it is the cloud is negative, right. So, note that distribution negative along the stroke path, right. So, all the plus minus signs are shown in this diagram, right. So, this process of dart leader and return stroke, that is figure 14f, right, this is also shown here also 14f, right. The process of dart leader and return stroke can be repeated several times. I told you, if you observe during thunderstorm you can see that the complete process of successive stroke is called lightning flash. So, when lightning happen you have observed that, right, and that noise comes due to the air breakdown, right. Therefore, a lightning flash may have a single stroke or a sequence of several discrete strokes, as many as 40 it can happen, separated by about 40 millisecond, right, as shown in figure 15. So, this is actually figure 15, right. So, dart leader, return stroke, everything is shown, right. So, therefore, I mean this actually this as many as 40, when it is taking 40 means it will be a heavy lightning stroke, right. So, separated by about 40 millisecond as shown in figure 15 I showed you. So, this is how the phenomena of your lightning stroke. So, this is only we have talked about general lightning stroke, but we have not talked about when it is lightning stroke happen on the overhead transmission line, right, or indirect stroke, right. So, next we will come to the lightning surges, right. So, the voltage produced and overhead lines by lightning may be due to indirect stroke or direct stroke. So, this because our objective here is to the lightning, if lightning happens on a directly on the your shielding wire, that is that ground wire of the overhead transmission line you might have seen, or directly to the your conductor, or directly to the your on the top of the tower, right. These are direct stroke, and indirect stroke means maybe nearby trees or nearby ground that your lightning stroke has happened, and due to this some charge will be accumulated on the your ground wire or on the conductor, right. Those are indirect, your what you call indirect stroke, due to indirect stroke. So, first we will see the indirect stroke, right. In the indirect stroke, induced voltage can take place on the lines as a result of close by lightning stroke to ground. It may be very close that lightning stroke has happened, or maybe a nearby tree also. Because of that some charge will be accumulated on the either ground wire or on the conductor or on the top of the tower. Even though the cloud and earth charges are neutralized, because when lightning stroke has happened, that charge through the cloud and earth will be neutralized, totally neutralized, right, and the cloud to earth current path also established. Lightning stroke has happened, a charge will be trapped on the line. So, there is a possibility that charge will be charge will be trapped on the line, as shown in your figure 16a, right. So, this is figure 16, this is say some overhead line. So, lightning stroke has happened somewhere, right, but some charge may be accumulated on the your line conductor or tower or your what you call ground wire, right, or shield wire. So, in this case your a charge this thing, the magnitude of this trapped charge is a function of initial cloud to earth voltage gradient and the closeness to the stroke to the line. I mean how close that lightning stroke has happened, and of course, that cloud to earth voltage gradient. Such voltage may also be induced as a result of lightning among clouds, as shown in figure 16. I mean this kind of thing also can happen if there is a lightning stroke between two clouds, right, or in that case also this charge can be accumulated on the line, right. So, in any case, the voltage induced on the line propagates along the line as a travelling wave, right. So, in until it is dissipated by attenuation. I mean whatever it is, if your what you call any voltage induced on the line, it will propagate along the line, we call travelling wave, right, as a travelling wave until it is dissipated by attenuation. So, then due to leakage, insulation failure, or your lightning arrestor operation. Arrestor operation is there, but somehow I have to make it little bit condensed. So, only arrestor little bit arrestor different type of arrestor another thing we will not study in this course, but as arrestor is the your every substation you will find arrestors are there everywhere. Later his little bit function, what exactly it is, we will come to that, right. So, and in the direct stroke, the lightning current path is directly from the cloud to the line. That means, there is a direct lightning stroke on the your what you call on the transmission line. The direct lightning stroke may be happen in the middle of the line, maybe on the top of the tower, or maybe on the ground wire, right, or your shield wire, right, here it is, or on a line conductor. If it happens, if lightning hits a tower top, suppose it lightning has happened, this is very common phenomena. If lightning hits a tower top, so transmission tower is there, if lightning hits there, so some of the current may flow through the shield wire, because shield wire or ground wire will be connected on the, if you look through your on the top of the overhead conductor will be there, and on the top also that your what you call that ground or shield wire will be there. So, some of the current will be flowing to the shield wire, and the remaining current flows your tower to the earth, right. That means, rest it will go from the tower to the earth. So, in that case, that if the stroke is average in terms of both current magnitude and rate of rise, stroke is average means intensity is less, right. The current may flow into the ground without any harm, provided that the tower and its footing have low resistance value. If it has a low resistance value, it will get an easy path. So, your what you call the damage and other thing will be your what you call will be very less. I mean almost no damage, right. Otherwise, what will happen, that lightning current will raise the tower to a high voltage above the ground, because if you have grounding resistance, if the resistance path is high, then there will be what it does actually, it will raise your tower to a very high voltage above the ground, causing a flashover from your tower over the line insulator. I mean if it happens that from the tower and their line insulators also connected, there will be flashover between the tower and the insulator to one or more of the phase conductors, right, to one or more. So, in that case there is a possibility of the line outage also, right, and insulator also will be damaged. So, on the other hand, when lightning strike a line directly, the raised voltage at the contact point propagates. Suppose a transmission line is there, and where that lightning stroke happens, suppose in middle of a line, right. So, both sides that your what you call raised voltage will propagate, right, at the your contact point propagates in the form of a travelling wave, and both sides it will move in both direction and raises the potential to the line to the voltage of the downward leader. That means the potential will be whatever is the voltage of the downward leader, that is that coming from the cloud to the conductor, it will raise to that potential. So, imagine that how although it is for microsecond or so, but how your what you call its numerical value, it is very high actually. If the line is not properly protected against such overvoltage, such voltage makes it the line to ground fault withstand voltage, right. So, in that case of the line and of the line insulation and cause insulation failure, right, this will happen. So, proper protection is there, right. Therefore, such insulation failure or preferably arrestor operation, there establishes a path from the line conductor to ground for the lightning surge current, right. So, that is why that whenever your lightning arrestors are there in substation, if you go, you can see that it is designed in such a fashion such that it can what you call encounter a minimum amount of current for which it protects the other equipment in the what you call in the substation. But even when they design this, they consider all the facts, and accordingly that engineers they design the your minimum rating of the lightning arresters. But even so, even with that what will be the maximum your what you call the maximum lightning currents or maximum or what you call that intensity of the lightning stroke that they calculate. But even practically I have seen in some substation in my young age that even at the substation that lightning arrestor failure, it got burned. I mean maybe that maximum intensity of the stroke was very high, could not your encounter this one. I mean, so that is why it will mainly damage first the transformer at the substation, right. So, that is why that or your what you call such insulation failure or preferably arrestor operation establishes a path from the line conductor to ground for the lightning surge current, right. If the lightning strikes an overhead ground wire somewhere between two, I mean if it is not exactly the conductor, but top you can see the ground wire is there, it causes a travelling waves along the overhead ground wire. It will be the same phenomena that overhead there will be travelling wave. So, lightning current flows to the ground at the towers without causing any damage, provided that the surge impedance of towers and the resistance of the tower footing are not high. So, it will if tower footing resistance is low and that surge impedance of the tower, then what will happen that it does not cause much damage, but otherwise what will happen that if surge impedance is high, then on the top of the your what you call the tower top voltage will be impressed across the line insulator string also and can cause a flashover resulting in a line outage. So, that means when they design just when you look into that transmission tower and footing resistance, all these things they design it in different way. So, from distance we can see many these things, but actually many engineering concepts are there for your erecting towers and the insulators as well as your footing resistance. Their engineering concepts are there, just not like putting the your what you call that erecting the tower, and design of the tower also we can see different kind of designs are there, although we will not study tower design here, but different type of designs are there, insulators are there. So, lot of engineering concepts are there behind that, right. So, it is your what you call possibly that the arcing from the sometimes what happen that arcing from the ground wire to the phase conductor may be sustained. That means, if that your the top of the tower, if you see the sealed wire has gone, the ground wire and the conductor, sometime that arcing thing it may sustain. At that time you have to what you call this for 50 hertz or 60 hertz line voltage, and it can only be removed by de-energizing the line. This phenomena is known as backflash, right. Sometimes actually nowadays several techniques are there. For example, suppose a high just general phenomena, suppose first you take a line, right, conductor, suppose it was carrying current or power, say high tension line, for example say 220 kV line. Now, suppose load is disconnected, line is switched off. So, according to that, so line there will be no current flowing because load is switched off, but line is charged. The reason is that that line overhead conductor to the ground, there will be uniformly distributed capacitance will be there, although line is not carrying your power or current, but line will remain charged. So, if suppose with that without any caution, right, for example, I mean just giving an example, any human being, say if we take a conducting rod and if you try to touch the line, that person will die actually, because this discharge will take place, discharging will take place through the body of the your what you call through the body of the person, right. So, what they do actually, both side of the line you have to ground it such that it will be that line to charging capacitance first will be discharged and after that you can work. Nowadays you can see online they are working even with a lot of protection, right, but this is the phenomena that if this line is still remain charged, right, then you have to first discharge it, and in this case that sometimes it happen at the 50 or 60 line voltage there may be arc formation between your overhead the ground wire and the conductor. So, in that case you have to de-energize the line first, and this phenomena sometimes they call as a backflash, right. So, it is most prevalent when footing resistances are high, but can also occur on tall towers with low footing resistance. If tower is tall, it can also happen that, but otherwise your what you call when footing resistances are high, this may happen, right. So, this is your what you call lightning stroke and on the conductor. So, these are general ideas. So, all if I miss anything, so some things I have brought for all of you. So, now cause of switching charge over voltages. Whatever we see that switching charge, that is one thing we saw, that due to lightning that over voltage is there, but question is that operation of circuit breaker produces transient over voltage. However, the concept of switching should not be limited to the intentional actions of opening and closing of circuit breaker and switches, but may also include the arcing faults and even lightning, right. All these things can happen. The causes of switching charge over voltages can be summarized as follows, right. So, it may happen normal line energizing or de-energizing, this is one happen, and high speed different type of switchings are there. I have decided I should not cover here because it will take then I mean long time, right. So, normal line energizing or de-energizing, high speed line reclosing, right. So many things are there, right. Next is your then switching cable circuit, capacitor banks and shunt reactors. Then load rejection, this is a question to you, very simple thing. What is load rejection? From common sense you have to tell, just this question I am putting, what is load rejection, right. I am not answer that, this is for you, that what is load rejection. Then out of phase switching, then reinsertion of series capacitor. Many high tension line, sometimes 132 kV or above, they use series capacitors. Of course, their resonance is a problem, that this thing thing you have to consider not only at fundamental frequencies, some third or fifth your what you call third harmonic, fifth harmonic, all these things you have to test for resonance, but high tension line for maximum increasing the maximum power carrying capability, series capacitors are also there. So, this thing, then circuit breaker restriking, right, and current chopping, these are the thing that you have to consider for your what you call that your switching charges, right, over voltages. Whereas, the 50 or 60 hertz voltages are caused, 50 hertz 60 hertz means in many countries 60 hertz system is there, our country it is 50 hertz, right. Example of these conditions are voltages on the unfaulted phases during a phase to ground fault, that you have studied in your power system analysis, right. So, suppose a phase to ground fault has happened, then what are the voltages on the your unfaulted phases, right. Then load rejection again here also coming, and another thing is open end of a long energized line, that is Ferranti effect. You know, in the Ferranti effect receiving end voltage will be more than sending end, that we have seen, and another thing is ferro resonance, right. So, all these things happen, that this is causes of switching charge over voltages as well as at the normal your 56 hertz voltages. So, thank you very much, we will be back.